Hello everyone, in this video we are going to discuss this question: insert node at the ith position. So first let us take an example. So let's take array. So suppose this is your array and you want to insert an element at this position. Okay, so you want to insert one element at this position. Then what you have to do, so let's say these are the values present in the array. So 1, 2, let's say 5, 20 and -5. So these are the values that are present in the array, and you want to insert, let's say, data 100 at this position. So this is 0, 1 and 2. So you want to insert data 100 at position 2. So how you will be able to solve this question in case of array? So what we have to do, so we have to shift all these elements. We have to shift all these elements towards right by one position. Okay, and we can only do that if I have a space available. Okay, so what we will do, we will shift the elements. So 1 and 2 will remain at their correct position. Then we will shift these elements. So 5, 20 and -5. So we can only shift element if there is space available. Otherwise, we cannot perform this operation in case of array. Okay, and then what we will do, so at this position we will insert our element 100. Okay, so at this position I will insert my element 100. So this is the way we will be able to solve this question in case of array. Okay, so I'm repeating myself. So what you have to do, so if you want to insert an element at an index in case of array, so you have to shift those elements by one unit towards left, and you can only shift when there is space available in the array. Otherwise you cannot shift the element and you will not be able to perform this operation. So after shifting the elements towards right, you can insert the element 100 at position 2. Okay, so this is position 0, position 1 and position 2. Now let's discuss what will happen in case of linked list. So this is your linked list 1, let's say 2, 3 and 4. So these are the indexes 0, 1, 2 and 3. Now let's say you want to insert data 100 and at position 2. Okay, so you want to insert data 100 at position 2. So in case of linked list, it will be very simple. So what you will do, you will reach at position 1. Then what you will do, you will create a node with data 100. So create a node with data 100. Then what you have to do, so now this 2 will point towards this node 100 and this link will be broken, and this 100 will point towards this linked list, sorry, this node 3. Okay, so we will get our updated linked list 1, 2, 100, 3 and 4. So in case of linked list, inserting one element at a certain position is very simple. You do not have to shift any element. Okay, so what will be the return type of my function? So the return type of the function will be node star. You will return the updated linked list, basically the head of the updated linked list. Then the name of the function will be insert node, or you can say insert at ith position. Okay, insert at ith position, and what it will take as input, so input will be linked list. So by linked list we mean the head of the linked list. It will take which data you want to insert, and it will take the index, the position at which you want to insert your data. Okay, so in this video we are only discussing the question. Okay, so in this video we are only discussing the question, and I will discuss the solution for this question in the next video. But what I want you guys should do, so you guys should try to implement this function, basically try to complete this function by yourself. Okay, and what you have to do, so you have to consider the special values of I. Now if the value of I is basically less than 0, so less than 0 means we will not insert anything. Okay, so if the value of I is less than 0, we will not do anything. Similarly, if the value of I is 0, that means I will insert at head position. By head I mean, for example, if this is your linked list 1, 2, 3 and 4, and let's say instead of I it's 2, instead it is 0. So what you will do, you will insert 100 at this position, and then you will make this connection. Okay, so this will become position 0. So you have to handle this case, and one more special case will be there when the value of I is basically greater than the length. So in this case, so if this is your linked list 1, 2, 3 and 4. So this is index 0, index 1, index 2, index 3. So what is the maximum valid index? So the maximum valid index can be index 4. Okay, and 4 is basically the length of the linked list. 4 is the length of the linked list. So the maximum valid value. So the maximum valid value of I can be the length of the linked list. Okay, so if this is the condition, I is greater than length of the linked list, that means the index is not valid. So in that case also we will not do anything. Okay, so in these two cases my index is not valid, so we will not do anything. Okay, now in rest of the cases we have to do simply like this. We will create a node and we will make the connections like this. We do not have to do anything else. Just simply changing the pointers will do our work. Okay, so you can see this is the benefit of using linked list. You do not have to perform the shift operation. Okay, in this case we have to perform shifting operation. Okay, we are shifting every element towards right hand side. Now as a hint, what you can do, so if you remember, we have solved the question print ith node. Okay, so what you can do, so we have already solved this question print ith node. You can take help of this function to complete the function. So again the return type will be node star. You will return the updated head of the linked list, and the name of the function is insert at ith position. So what it will take a head as input, head of the linked list as input. It will take what data you want to insert and the position at which you want to insert. Okay, so I hope you guys can write the code for this function yourself. So first you should try writing this code by yourself, and then in the next video you will see my solution. Okay, so watch solution later. First try it yourself. Okay, so you can take the help of this function. Okay, so I will see you in the next video. Bye bye.